Hey everyone. In this video, I wanted to spin up a MPLS L3VPN from pretty much scratch. So this is the network that I'm going to be working with. And you can see we have two customers, red and blue. And then we have our MPLS core. So all I have on this network so far is really just IP addresses. So let's go ahead and get started. The first thing I need to do is in the core routers, which is going to be routers 1 through 6. You can go back to here. We're going to have routers 1 through 6. I need to first enable an IGP. So I'm going to do router OSPF 50, and I'm going to enable this pretty much just everywhere. So we'll just do network 0000 255 area 0. And this is so that I could announce all the loopbacks into the network. Now, the next thing I'm going to have to do is enable MPLS. So I'll get out of configuration mode, or get out of OSPF configuration mode, and I'm going to turn on MPLS, and then I'm going to make sure that all my routers are using the loopback as the router ID. So it's MPLS LDP router ID loopback 0 force. Now, if we wait a few moments, we should be able to see. First, let's do show IP OSPF neighbor to make sure OSPF is up, which it is. And then show MPLS LDP neighbor is not up yet, which is fine. It might take a moment. Well, actually, it wouldn't because I didn't enable MPLS completely yet. Conf T. Let's go back into router OSPF 50. Router OSPF 50. And I actually have to turn this on the interfaces, which was the step I forgot. But in this case, I'm just going to bind it to OSPF and turn it on all the interfaces where OSPF is also turned on. So we'll do MPLS LDP auto config. And this is just going to save me a little bit of time. So now, if I do show MPLS LDP neighbor, now we can see we have some neighbors. And each router in my network should have 2. So 5 is 1 and 3, 1 is 2 and 5, 3, etc. So you have 2 neighbors, you have 2 neighbors, 2, all right. So now pretty much the core of our MPLS is up. There is one more thing I do kind of want to do though, and this is more of a troubleshooting thing than anything. So let's say I go to 5 and I ping over to 6, which these are my 2 PE routers, or so let's say trace, I'm sorry. If I trace over there, you can see the labels are not too descriptive, but that's because the labels are locally significant only. So in my case, what I want to do is I'm going to go to each individual router, and I'm going to use the MPLS label range command. And in this case, I'm going to say the range is going to be from 1 to... actually, I'll do 100 to 199. My syntax is just off there. 100... Oh, there's no dash. It's just 199. Okay. This change will cause the old labels to go out of range. Right. So let me do this on all the other routers. So 2, I'll comp the MPLS label range. I'll do 200 to 299. Label range 300, 399. Label range 400, 499. $5.99. Okay. So it will cause these labels to go out of range, etc. Now, there's nothing I could do about the current labels that were already learned. So if I do show MPLS forwarding table, I could see I do have a new label. It looks like for here, but all these labels I can't change yet. But that's okay because I'm not really concerned about looking at the traffic within the network. What I do want to pay attention to though is the traffic outside because I want to do some traces from red to red or blue to blue, whatever. So now that MPLS is up and running, what we need to do is configure our PE to CE routing relationships, peering relationships, I should say. So what I'm going to do is, since I'm on R6 and I'm connected to both these routers, is the first thing I do is take R6 and add a BGP configuration on there. And specifically, I'm going to need to peer with R5 in an IGP relationship. So let's go ahead and get that configuration started. So the first thing I need to do is create some VRFs. So we're going to do two VRFs. We're going to do VRF I can't spell definition red, which we're going to enable for the address family of IPv4. And then for red, because both of them are going to be in AS79, I'll just do AS79 as where. Okay, I don't know why that was, but we're going to do a route distinguisher, and I'll say it's 7979.
Sorry, I don't understand.
Google decided to answer me for some reason, but a route distinguisher of 7979, and then route target, both. So I just want to show you this. Import and export, if you do both, it inserts both commands. So we'll do a 7979 as well. And that'll be our first VRF. Then we're going to do a VRF for blue. And this one is also going to be address family IPv4. And this one, let's see what we want to do for a route target. One is 10 and one is 8. So let's do 108. So let's do 108, 108. And then the same exact thing for our route targets. Route target is 108, 108. Now, these two numbers don't need to match, the route distinguisher and the route target. But in my case, I'm going to just because it kind of makes things easier to look at. So now that I have a VRF set up, I need to configure this on the other side. So instead of spending a ton of time doing that, I'll just do a show run section VRF. I will copy this, go to R5, insert, and it's the same thing. All right, so we have our VRFs. Now we need to configure BGP to get within those VRFs. So let's, I could stay on R5, that's fine. I'll do conft, and we're going to do router BGP 50 because this is our AS. And I'm going to do no BGP default IPv4 unicast because I don't want neighbors by default to jump into that address family. I'm going to want to do the VPN4 address family for my PE to PE connections, and then I'm going to want to do the IPv4 VRF address families for my PE to CE connections. So now that I have this command on here, I can do a neighbor, and I'll do neighbor 6, router 6, and it's in the same AS as me. And I'm also going to set the update source to be loopback 0. Loopback 0. Okay. Now, here's the address family I want to put this into. It's going to be VPN v4 unicast. And I will do neighbor activate. Activate. Sorry. Okay. Now I'm going to do, I just want to take a look at the running configuration of BGP because I want to show you something. This command is needed, but you notice I didn't actually put that in. It's automatically applied. However, it is possible to take the command off. So if you're in a troubleshooting situation and you don't see this command, that's a problem. And just to walk you through what I just did, I was just on R5, and we're going to create a BGP peering from 5 to 6. None of these other routers, 1, 2, 3, 4, none of them need to know about BGP. This is kind of the point of MPLS. We have a BGP-free core. So 5 and 6 will know about the routes. None of these need to know anything about BGP. So let's go ahead on to 6, and we basically could do the same exact configuration. So conf t router BGP 50, no BGP default IPv4 unicast. And now this time we'll just do neighbor 5.5.5.5. Remote AS50. Whoops. Remote AS50. I'll do an update source of loopback 0. And again, we're going to go into the address family of VPN v4 unicast. VPN v4 unicast. And activate. All right. So now that we have that in there, we can take a look to see if our BGP neighbor is up. Now, if we did a show IP BGP, we're not going to see anything. Show IP BGP summary, we don't see anything. Not even our neighbor configuration. That's because with MP-BGP, we need multi-protocol BGP. Excuse me, I should explain some of the terms I'm using. We have to do show BGP VPN v4, and now, well, we do unicast as well. And now we have a couple different things. We could say all, or we could do a VRF, but I'm just going to do all. And here are your normal BGP, commands we would normally look at. So I'll just do summary because I want to see my neighbors, and we could see we're up. We haven't sent or we haven't received any prefixes, but that's normal. We don't have anything to send yet. So let's take a look at, now that we have our IGP, LDP, so MPLS is running, we have our PE to PE BGP. Let's actually start routing some traffic for customers. So let's take a look at Red. Red has 2 routers. We have R7 and R9. And R7 is going to be connected to R5, so we'll focus on this one first. So let me pull up R7. And R7, I don't believe, has any. We do. So looks like I already put some configuration on R7. I think that's because I wanted to make this video go by a little bit faster. I didn't want to make a 30-minute video. So on R7, we could see the BGP configuration is super simple. All it is we're redistributing our loopback, which show IP. The loopback address is 192.168.7.1. Nothing complicated. But anyway, we're redistributing the loopback, and here's our neighbor, which is R5. So from R5's point of view, what I need to do is, conf router BGP 50. I have to go into a different address family. My address family is still IPv4, but now it's a VRF. And this VRF is red. Now under here, I'm going to create a neighbor. And the neighbor was this address. And the remote AS was 79 actually, I believe. Let me double check my, 79. Okay, so neighbor remote AS 79. All right, and let's check to see if it's up. Show IP BGP. Show IP BGP summary. All right, so the neighbor is active. It still hasn't come up yet. We'll just give it a minute here to cook. Well, let's ping this to make sure that I can actually. And if you were paying attention, you probably know what I did wrong. And that's I didn't put my interfaces in the VRF. So this configuration, it's really easy from a BGP point of view. But the one thing I forgot to do is show IP in brief is I actually don't even have a configuration at all there. So let me do int gig 1 dot, what do we got here? Show run int 1.57. All right. I'll just copy some of this. Actually, VRF forwarding red, and then IP address is going to be 51.57.5, I believe. Let me just double check. 57.5. All right. So now that I have that going, now we can ping, show IP BGP summary, and now we're up. All right, so what I'll do is I'll quickly pause the video to go ahead and configure the router on the other side. So hold on one moment. All right, so I'm back, and you can see my basic configuration on the customer side. Just really a couple lines. We're redistributing the loopback, and here's our neighbor. And now we can see the neighbor is up. The one thing we will notice, though, is that we haven't received any prefixes. And the reason why is because our customer is BGP 79, and on the other side is also section router BGP is also BGP 79. And now we know from BGP this isn't going to work, because if BGP sees its own AS in the AS path, it's going to drop the packet. And I mean drop the route, excuse me. We have two ways of overriding this feature. We can go on the customer side and say allow AS in, or we could do it from the provider side with the AS override. I'm going to do it from the provider side because I want to keep my customer configurations as simple as possible. So what I'll do is go to R6, and we'll do conf router BGP 50. We'll go back into our address family, IPv4 VRF red, and we just have to configure neighbor AS override. I'm going to have to do the same thing on the other side. So let's go to R5. Let me get some separation here. Router BGP 50. Address family IPv4 VRF red. Neighbor was, what was my neighbor? Was this? AS override. Okay. Now, if we look at the customer side, we see we actually are receiving a prefix. And if we show IB-BGP, here's my loopback that I'm locally sending in, and there's my remote loopback. So let's try to go ahead and ping dot. What was it? Was it .7 or .1? Show IP was .1. Okay. .1 source loopback 0, and we can ping. So our customer can ping. And now what we can also do is we can do a trace. And we could see the labels that are coming through. Now, the labels are 500 because I didn't reload the routers, and I still I probably should, but you could see 19 and 19. I just wanted to show you that command on how to set the MPLS label range. If I reload the routers, which I will do in the future, it'll make our output a little bit prettier. But anyway, we could see that we're going through 6 to 2 to 1 to 5 to 7 through the MPLS core. Now, the nice thing about MPLS is we have this network here, 10.0.10.0/24. If I go into one of my other routers, which is R10, or my other customer, excuse me, this is customer Blue, I believe they have the same network. And they do, 10.0.10.0. So if I have two customers with the same prefixes, how does that work? Now, I'm going to pause the video for a moment just so I can configure both the customer or both the Blue routers, because we don't need to see that again. This video is already getting pretty long. So let me go configure that really quick, and then I'll just go over it briefly. All right, so I'm back, and I wanted to show you first the PE configurations that I added, which is very simple. It's just VRF Blue, remote AS8, it's activated there, and then 6, again, I have VRF Blue, and this neighbor here. So if we look, that's router 8 and router 10. So router 8, I already did a show IP BGP because I was just verifying, but we could see I'm now learning this network, and I think that's it. And router 10, let's do a show IP BGP. I'm learning the .8 network. So I should be able to ping across 192.168.1 source loopback 0, and I can. Now, remember what I was trying to show you is R10 has a 10.0.10.0/24, and R9 also has that same network. So how do we know that they're different? So this is really the beauty of MPLS, because we're going to have clients, customers, who all use RFC 1918 networks, and more than likely they're going to have overlapping IP addresses. So let's say from R8's perspective, when I'm going to this network, how do I know that it's going to the right router? Well, I can trace 10 to 1, source is loopback 0, and I can see that it is actually going to R10. But how do I see this from the point of view of, our MPLS routers? And what I can do is go to one of my PEs, and let's do a show BGP VPN v4 unicast. And this time I'm not going to do all. This time I'm going to do VRF red. And I think that's just going to be it. So we could see the routes for VRF red, and we could see that these routes have the route distinguisher of 7979. If we take a look at VRF blue, we see, yes, we have the same prefix, but the route distinguisher is 108, 108. So how does that look when we actually dig into one of those routes? Well, we could do the same thing we did before. Well, let's say VRF blue, and let's say 10.0, 10.0 /24, and you'll see that this is the BGP routing table entry for 108:108 prefix. So if we did this for red, again, the routing entry is actually 7979 with the prefix. And that's our route distinguisher. So this is how BGP is going to tell these routes apart. And this is why we can have, millions of customers who all use the same RFC 1918 addresses. This is a pretty long video, but we went from just having 10 routers with almost nothing configured on them to configuring OSPF, LDP, multi-protocol BGP, VRFs, and configured BGP in a PE to CE peering relationship. So this is probably a little bit long-winded, and I'm coming up almost on a half-hour long video. I hope it was somewhat enjoyable if you stuck with me, and I'll see you on the next one.